Okay. Did you have a good weekend? Yes? Okay, so we're going to get started here. Let's see, when do we have our first exam? Seems like it's around the corner somewhere here. October 3rd. It's my brother's birthday. What's that? It's your birthday too? Okay, you don't have to take the exam. No, I'm kidding. I'm kidding. So we've got, another couple of weeks before the exam. Today we're going to finish up 1.2. We didn't quite finish that last week. We're going to jump, as you can see, from chapter 1 to chapter 4. And there's kind of a reason for that. You'll see when we get to it. Thursday, I plan on having your first real quiz where it's just you taking a quiz. And we'll do that at the beginning of class. And we'll do probably one or two problems, maybe one from each section. And they'll probably be somewhat similar to application problems from the homework, which means word problems from the homework. So make sure that in the homework you've gone through the word problems, and if you have any questions, you ask them at the beginning of class next time. All right, because I'll answer maybe one or two questions before the quiz. And then now we're going to finish up what we were discussing about lines. So remember, linear equations in two variables, those are lines. We have three different forms of lines. We talked about the first two, the standard form, and we talked about the slope-intercept form. And we talked about the advantage of having slope-intercept form is that it's easy to graph, but you can graph them either way. And then we did not talk about the point-slope form, which is what I'll pick up with right now. So go ahead and jot this formula down. It says y minus y1 equals m times x minus x1. And let me add something to this. We usually use the point-slope form. Use this if you're given a point and the slope. And that's where it gets its name from. The point-slope formula is the formula that you use when you have a point on the line and the slope of the line. If you know those two things, then we want to use this formula. Here, the point that we would use, the point here, would be given to us, x1, y1, and that would be plugged in right here. Those values would go in right there. And then the slope we're also going to be given in the problem. That's your m. And of course, that would be right there. So once you plug those numbers in, you'll have the equation of the line. Now, also, we talked about slope last class in terms of, the slope of a line being positive versus negative, slope being 0, and slope being undefined. But we never actually wrote down the exact formula for slope. So if you're given 2 points, okay, if you have 2 points on a line, then we can call the points x1, y1, x2, y2, and then the slope is defined to be the difference in the y coordinates divided by the difference in the x coordinates. But it's important that you do this computation correctly, meaning you take this y coordinate, subtract that y coordinate, and then divide it by this x coordinate divided by this x coordinate. You can't switch them. You can't do this y minus this y, and then this x minus this x. If you do it backwards, then it'll be wrong. Understand? Okay. All right, so let's just do a problem here where I give you a slope, and then I give you a point, and then we just come up with a line, and then we'll graph it. And then we'll get to a word problem. Okay. Find equation in slope-intercept form of line through the point, let's say 5, 3, with slope of -1/2. Find equation. Sorry, EQ. I'm abbreviating here. Find the equation. Yeah, if you ever have any questions on my abbreviations, just stop me. Find the equation in slope-intercept form of the line through this point and given this slope, and then graph. Graph it. All right, so what is it that we're being asked to find here? The equation, right? We want the equation of the line, but we want the equation of the line in slope-intercept form, right? That means we want our final answer to look like this, right? That's what we want our final answer to look like, y equals mx plus b. However, we're given a point and a slope, right? So we're going to use the point-slope formula to start. So I'm going to write down the point-slope formula. We're given a point, 5,3, and a slope of -1/2. And so I'm going to use this formula, y minus y1 equals m times, in parentheses, x minus x1. So this is just plugging numbers in. That's all we're going to do now. So for us, what's y1? It's just 3, right? So we're going to rewrite this, y minus 3 equals m. M for us is the slope, right? So -1/2. And then parentheses, what? X minus 5, right? So there's our x1 right there. Now this is an equation of the line. I mean, this is an equation. It is a line, but it's not yet in slope-intercept form. So do you all remember what I said the big thing is here for slope-intercept? Like, what do you really have to do to get it to look like this? Get y by itself, right? Solve for y. That's the big thing. Solve for y, make sure you don't have any parentheses left, right? And then it'll look like this. So I'm going to start this by first distributing the -1/2 through the parentheses. I'm going to start with that. So y minus 3 equals, so -1/2 x, right? And then what? What's a negative times a negative? Positive, right? So we got positive 5/2. And we're going to leave it as a fraction. We're not going to change it to a decimal. Now, yes, we almost have y by itself. We need to get rid of this -3, so we're going to add 3 to both sides. So we're going to have y equals -1/2 x plus 5/2, and we're adding 3 to both sides, so plus 3. Now, I haven't actually added the 3 yet, right? You need to combine these together. And how do you add those two? What are you going to need to get? Common denominator. So I'll just do that little scratch work on the side here. If I'm going to do 5/2 plus 3, right, I'm really doing 3 over 1. And then get a common denominator. So this is 5/2 plus what? 6/2, right? Just multiplying top and bottom here by 2. And now you can add straight across. That's 11 over, keep the denominator 2, 11/2. So I think we're ready for our final answer here. Y equals -1/2 x plus 11/2. That's it. That is the equation of the line in slope-intercept form that goes through this point and has that slope. And the last thing to do is to graph it. All right? So let's go ahead and graph. So if we're going to graph this, let's see, I'm going to start calling on people. I gave you the first 5 minutes to wake up. All right. Okay. Now, if I already called on you last class, just tell me I called on you. I think I can tell who I called on here. How about Jordan, did I call on you? Where's Jordan? It did, right? Okay, how about... Oh, I read it wrong. How about Kobe? Did I call on you? Or did you volunteer? No? You volunteered? Okay. Dylan? I did? Shit, man. Okay. All right, well. How about Brett? No? All right, Brett, how you doing today? You ready? All right, Brett. So if I asked you to graph this, Brett, how would you go about it? What would you start with?
Graph the y-intercept.
So you go get that point?
Yeah.
So what would that be? I guess you would have to get a decimal,
Yeah.
right? So 11 divided by 2 is about, what? 5.5? 5.5? So you would go on, where would I put that? The y-axis. Okay, so I'm going to go up 1, 2, 3, 4, 5. Here's 6. Here's 5. So 5.5, somewhere around there. You want to keep going, Brett?
And then from that, you graph the slope.
Okay, so from that point, and where would you head? Where would you go?
You're going down to the right.
Down 1 and to the right
Yeah.
2. Perfect. Yep, that's it. And then once you have that, once you have 2 points, you can draw a straight line. If you wanted to, you could go down again 1 and to the right 2 and get another point, and then do it again to get more points. But once you have 2, you can draw a straight line, and you're in business. I went down 1 because when we have -1/2, and this is, I'm glad you asked this question. What we need to keep in mind is that means -1 over 2. Okay, so a negative out front really means a negative on top and a positive on the bottom, like this. Or you can have 1 over -2. These are both the same. Now, if you do it this way, you're going to go down 1, right 2, aren't you? But what if you do it this way? I'm saying this is the same thing. What would you do here? Up 1, left 2. But if I go up 1, I'm here, and then left 2, I'm still on the same line. So it doesn't matter which way you do it. The important thing is that when you have a negative, you don't do negative on both. It's either negative on top or negative on the bottom, one or the other. Okay? Okay, thank you, Brett. Now, let's do an application problem, all right? Because this is a business math class, and our whole goal is to be able to solve problems that are related to business, which means word problems, which are your favorite, right? I'm working off page 21. I'm just going to work example 8, all right? But I'll read it out, and I'll write it out. At a price of $9 per box of oranges, the supply is 320,000 boxes. And demand is 200,000 boxes. Period. So let's just try and understand what that means. In this particular model, for this particular company that supplies oranges to, let's say, H-E-B or something, if they charge $9 per box, they're going to be able to supply 320,000 boxes. All right, that's what they can supply. However, at that price, the demand for the boxes is less. It's only 200,000, all right? So now, if we change the price at $8.50 okay, per box. The supply is 370,000 boxes, and the demand, did I write that down right? Sorry, this was 270, thank you, 270, and then the demand is 300,000. So if they reduce the price per box, they're going to only be able to supply 270,000 boxes. But the demand is going to go up because the prices come down, right? Now, let's just think about this in terms of a business. Why is the supply changing with the price? I mean, you would think, like, you've got your trees, you've got your oranges, there they are. You're going to have the same amount of oranges no matter what you charge for, right? What do you think could affect the price? I mean, the supply. $9, I can supply this many. At $8, I can only supply this many. Why? Do y'all understand the question? Like what? Like, give me an example. The orange example here.
The more you sell, the more revenue you get, but also the more cost you have, so the price goes up.
Yes.
It's only a matter of business if you look at it. It's like you can only sell so many at a price. You see a whole different chart in that's microeconomics. You can see like chart and.
Yeah, but I'm trying to get you all to think of, like, I know oranges is kind of boring, but like, if you're selling oranges and you're able to sell them for $9 a box, then why is it that you can supply more than if you charge $8.50 a box? It looks like you can supply less. I'm trying to get you to think of an example. There's no right or wrong answer here. We're just trying to think of why this situation might happen. Yeah, okay, good. So if you're going to charge $9 a box, right? If you charge that much, you know you're going to be making more money, right, than $8.50 per box. And that money you can turn around and pay people to pick more oranges, right? And you can process more oranges at a higher cost to the customer. You're going to be able to do more work, and so you can supply more oranges. But if you bring the price down, then you can't pay everyone to go out there for the hours to process the oranges, so you may not be able to supply as many. Does that make sense? All right. So it's important to understand that in a word problem like this, that we just don't do it and get the answer and like we're done, because it's about business. We're trying to think through why things like this might happen. Okay, now, what about on the demand side? On the demand side, the customer, why is it at $9 per box the demand is $200, and at $8.50 per box it's $300? It's cheaper, right? So, you go into H-E-B and at some point you look at a gallon of milk, you're like, shit, that's too much money. I'm going to go somewhere else. In fact, I usually buy my milk at Valero. Like Valero's usually cheaper. What's wrong? You've never bought your milk?
Every time I go there, they're like $4.50.
Really?
Yeah.
I've had good experience then. I guess at my local Valero it's been cheaper. I think they water it down or something. I don't know. But I've had situations like that, and that's just as customers. Like I was just at Home Depot earlier this morning. I was getting ready to buy something, and of course, what I do, look it up on Amazon. It's $10 cheaper, right? So you're always as a customer looking for the cheaper price. So if this price is $9, people are still going to need oranges, but how bad do you need them? But if the price comes down, well, okay. So these things. This is what makes business models complicated. This is a relatively simple model, but you have all the factors involved, right? Price and demand and supply and how they affect each other. That's what business is all about, right? Trying to figure out what's the best thing for your business. All right, well, what's the question? Let's see here. All right, it wants us first for part A. Find a price-supply equation. Price-supply equation. of the form P equals mx plus b, where P is the price and X is the supply.
That's just like the finding the slope-intercept, but just,
Finding the what?
isn't that like the y equals mx plus b?
Yes, that's exactly y equals mx plus b. And they want us to actually find the equation that connects your price and supply together. All right, that's what this means. Find a price-supply equation. That means you want to find an equation that somehow relates price and supply together. And it should be a linear equation. It should look like this. Understand? We'll go through it. But part B says, same thing. Find a, this time, price demand equation. That's equation. Of the form P equals mx plus b. But this time, this is price, and this is demand. Now, they also say something about the supply and demand. For this X, they say in thousands. So if I say X is 1, I really mean 1,000. If I say X is 2, it means 2,000. If I say X is 13, that means 13,000. Right? So same thing with this one, in thousands. And then part C, they want the equilibrium point. Find equilibrium point, or do they say break-even point? Okay, I'll say point of intersection, because that's what they say. So basically, we're going to have two lines, right? We're going to have two different lines, and we're going to want to graph them, and we're going to want to find where they hit each other. And then we'll talk about what that point means. All right, so let's start off with that first part A. And I'm going to leave the word problem up here. I want the price-supply equation. So price-supply, if we look at this like a graph, it looks like this. Price, supply. Okay? Our supply is the x-axis, our price is the y-axis. So let's talk about price and supply. Is there anything you can tell me about price and supply? Give me some relationships. Anything you know about this from this word problem? We're talking about supply here. When it's $9, right? At $9, what? The supply is 320,000. Right? This is a relationship we have here, right? At $9, we have 320,000. Now, how could I write that as a point, as an ordered pair? What goes here? 320? Why 320? Because the x-axis, right, is this number, and that's supply, isn't it? And supply is the 320,000. So most common mistake I see here is that people will put 9 here and 320 here, but it's actually backwards because of the way the graph looks. So this is 320,000, or what is this? Just 320, right? Remember, it's measured, supply is measured in thousands. So 320 here, and then what goes here? 9. Okay, so that's one thing we know about the price and supply. Is there anything else we know? At 850, the supply is 270, right? So that's another ordered pair I have. 270 and 850. Y'all agree? You need 2 points to define a line, don't you? 2 points. So I could actually graph these, couldn't I? I could go over here and graph them, but we want the equation. We want the equation. So remember, our goal here is to try and get, we want P equals mx plus b. Any ideas on how we can do this? Anyone? Yes, go ahead.
You do the y2 minus y1.
Okay, so you're suggesting, since we're given 2 points, right, we can find the slope. And we'll be able to get this, won't we? Okay, so I agree. I like that idea. Let's go get the slope first. And I think I'll do that right here. Using that information, my slope will be equal to y2 minus y1 over x2 minus x1. And so I'm going to subtract the y coordinates. So what do you say we do this minus this over this minus this? Is that okay with you? So let's go 9 minus 850 over 320 minus 270. And you should get 0.5 over 50. And what's 0.5 over 50? 9 minus 8.5. So if you need to, you get a calculator out. What is it, 0, 0, 1. That's your slope. I'm going to put m next to this. All right, I'm going to call on someone now. Uh-oh. Noah, did we talk last time? Where's Noah? Noah, where? You're Noah. Okay, did I call on you already? I did? Who have I not called on? Come on. Did I go around? Did everyone get called on? Okay. So I'll call on you. We'll go with you. Thank you. What's your name?
George.
George. There you are. Okay. All right, George. I'm going to lead you through this, okay? All right. So, George, what are we trying to find again? What is it that we're looking for? Eventually, yes. But right now for Part A, I'm trying to find this equation, right? Okay. What do I have? Right here I have what? 2 points, right? And what do I have here? A slope, right? You mean I have at least 1 point and a slope? What would you do if someone gives you a point and a slope and they're asking for the equation? What did we do in the previous example? What were we given in the previous example? You can look at your notes. I think I put up on the board what we were given. Given?
Oh, like a supply plan.
No. From the previous example, the previous problem that we graphed.
We were given a point.
I was given a point and a slope, right? In the previous problem, I gave you a point, I gave you a slope. I said find the equation, and we were able to do it, right? When we look at this problem here, we had 2 points. Well, we didn't know how to get the equation from 2 points, but someone suggested that we find the slope, which we did. Now, we actually do have a point and a slope again, right? Once you have a point and a slope, you can go to the point-slope formula. The question becomes, which point do you use? These are both supply, though, right? These both came from supply? We haven't talked about demand yet. So which point do I use? Or does it matter? Does not matter. You can use either one. All right? That's an important thing. If you have 2 points to work with, you get to choose. So I'm going to pick this one right here because it doesn't have any decimals on it. Okay, so I'm going to get to this eventually. But I first need to use the formula y minus y1 equals m times x minus x1. That will allow me to get my equation, then I can turn it into that. Now, for us, y minus, what's our y1 that we're using? 9. And then what's our slope? 0.001. Is it 0.01?
Yeah.
Oh, okay. I'm just up here listening to y'all, so 0.01? Is that why half of y'all were looking at me with a glazed look, or no? Or is that just because it's Tuesday and y'all are tired already? We're good? So that's y minus y1 equals m, and then here x minus 320. Okay, this is our equation, but there's one slight problem with it, just a slight technicality here. We've got x, and then we've got y. What should we change that y to in order to make it match our equation? P. We should really be talking about p here, but I'll do that on the next step. So we have p minus 9 equals 0.01 x minus 320. You all right? You all right? I want to try kind of get you woken up. You want to help me with this? Yeah, you. You look like you're kind of dozing off, so I'm going to save you from losing points on a test by getting you involved here. So do you know what to do here to get this?
The 0.01.
Just through? Okay. All right, so P. I can handle people dozing off if when I call on them, they know what I need to do. Okay? That's fine. But what's 0.01 times 320? 3.2. All right, last thing. Add 9 to both sides. So P equals 0.01x, and then plus what? 5.8. So when you add 9 to this, you should get 5.8. And this is it. That looks like y equals mx plus b, except p instead of y. We good? No, I added 9 to both sides because I'm trying to isolate p. So I add 9 here, it goes away. I add 9 to negative 3.2. So it gets 5.8. All right, we have answered part A. We have found the price-supply equation. Now, what about the price-demand equation? That's part B. How would you find the price demand? Same way, right? Same way, except you're going to use $9 and $200, and then $8.50 and $300. So we're going to have, for part B, price demand. I'm going to go a little faster through this one. We have, what is it, 200, 9, and 300, 8.5. You all understand where those are coming from? We're looking at demand now instead of supply. All right, I can get a slope from this. The slope is, let's do 9 minus 850 again. That's the difference of the y coordinates over 200 minus 300. So I get 0.5 again on top, and on the bottom, I get negative 100. Which is negative 0.005. Y'all following what I'm doing here? Okay, so now I have a slope, right, and I have 2 points. So I'm going to pick one of those. I'm going to pick the 200 and the 9, and I'm going to use this equation. But watch my equation. Check this out. I've kind of adapted my equation a little bit. Instead of saying y minus y1, I'm saying p minus p1. Because I know I'm going to have to change it to p anyway, right? So I may as well do it now. So it'll be P minus, what's P1 for us? 9 equals my slope, negative 0.005, x minus what? 200. Distribute through, P minus 9 equals 0.005x, and then what's that? What do we get? Plus 1. I'm off. I'm going to go off camera here, so let me move this over. P equals 0.005x. I'm going to add 9 to both sides, so plus 10. Understand the algebra here?
How complete were you that one?
Where I got what? The 1 distributing this through here and then through here. So I'm doing negative 0.005 times negative 200. This is my price demand, right? This is my price demand. And I have the other equation, which was price supply. So let me write them both down, or get them both together here. Price supply, that was part A, was P equals 0.01x, I've forgotten, plus 5.8. And then my price demand is P equals negative 0.005x plus 10. There we go. Those are my two equations. One of them represents how the price and supply are related. The other one represents how the price and demand are related. And so for part C, we are asked to find where these two intersect each other. So where do these two lines hit each other? So how do we do that? How do we figure out where they hit each other? We can graph them, right? We can graph them and try and figure it out. You agree? I could do that? That's going to be kind of tough to do, don't you think? What's going to be hard to do there if we try and graph it? What's going to be the most difficult part? The decimal on the slope, right? So like, how are you going to do this decimal, you know? Like up and over, like that's going to be tough, right? So maybe there's a better way of doing this, right? But could we agree on this at least?
Can't you find the points, the x and the y, and just kind of write it up there?
Find the x and the y?
Just solve for it.
Solve for x, yeah, something like that, yeah. We will. See if you agree with me on this though. If I were to graph this first one up here, if I were to graph this first one, where would I start at? 5.8. So let's say this is 5. Let's say this is 10. 5.8 is somewhere around here. Agree? What's the slope of this line? Positive or negative?
Positive.
Positive. So I'm going to have some line that looks like this. Right? What about the other line? Where's it going to start? At the 10, and then the slope of this one's negative, isn't it? And this one's going to go down like that. And our question here is what's that point? We know they hit each other, right? We know they intersect, but where? And I think this is a good place to actually just stop and start 4.1, because guess what 4.1 is about? How you find the intersection of two lines. That's what 4.1 is about. So let's do 4.1, and then we'll come back and we can solve this problem pretty easily after we do 4.1. All right? So we're going to leave that as an open question at this point. (4.1) systems of linear equations in two variables. All right, do we all know what a linear equation in two variables is? A line, right? A line. The only difference here is now we're saying systems of linear equations in two variables. And that word systems stands for we have more than one line. And for this book, in this section, it's actually we have two lines, and we're interested in knowing their intersection, all right? So solving a system of linear equations in two variables really means finding the point of intersection of two lines. All right, that's what it really means. Now, before we actually go through the technique, let's talk about some scenarios. Are we always going to get just one point of intersection? If I give you two lines, will you always have a point of intersection? No. It's possible that you don't. So here are some possibilities. First, we could have one solution, or I should say one point of intersection. And that would look like this. We have two lines. And they hit each other at a single point, and we're done, right? That's what we're hoping for most of the time happens. Can somebody tell me what a second possibility could be and what the picture would have to look like? They could be parallel lines. So what if we have two lines that are parallel? And what does it mean to be parallel? I don't think we talked too much about this. Not side by side, not touching. So two parallel lines don't ever intersect. Right? They never touch. Two parallel lines never intersect. So if I have two lines that are parallel, we're going to get no solution, right? Does that make sense? Are there any other possibilities? Two lines with undefined, both of them undefined? So you mean they're like both vertical? Yes, that would be good, but that would also be parallel. Like that would be this situation. If we turn these straight up, they're still parallel, so that would fall into this category. But is there another possibility where it's not parallel? And what if it's one line right on top of the other one? What if my two lines are actually the same line? Now this doesn't happen very often, but it is a possibility. And I can give you an example, but I don't think I will because it's not really relevant to this class. No solution, infinite solutions. Okay, that would be this scenario. I say, okay, draw this line, and then I ask you, where does it hit this line? And I draw the same exact line right on top of it. And so you're going to tell me it hits everywhere, right? Every point is a point of intersection. So not very common here. This might come up. This is really what we're going to be focusing on, point of intersection. Okay, so those are our possibilities. So let's start out now with an actual system of equations. Let's solve it. Let's try and find the point of intersection. And then I'll give you a couple of other techniques on how to do it. All right? Methods for solving systems of linear equations, two variables. I'm abbreviating everything here, but here are the methods that we use. There are three methods that we can use Now, the three methods we have nothing to do with the three different scenarios, okay? It's just there's three different ways to kind of do this process. The first one is just to graph them. Graph the lines and identify visually where the point of intersection is. Here's the problem with graphing. Not accurate. We would have seen that had we done that problem with the decimal slopes. It would have been very difficult for us to find that point of intersection. Now, if you use a graphing utility like graphing calculator, you might do a better job. But without that, this can be, imprecise. The second method is called substitution. And the third method is called elimination. Now, substitution is fast and clean, all right? It is a nice method for two equations, two variables. In other words, what we're doing right now is trying to solve systems of equations where we have two equations and two variables, right? That means the intersection of two lines. But as you proceed in mathematics, sometimes you have three equations and three variables, or four equations and four variables. And this method of substitution really sucks for those methods. For those situations. It's great for two equations, two variables, but not as good for 3 and 4 and 5. Elimination is longer, but works better for, I'm going to say, larger systems. Okay? By larger systems, I mean more equations, more variables. All right, so we're going to kind of throw the graphing out. Okay, we're not going to do the graphing. We're just going to go start with substitution. So let's do a real basic example first. And after we do the basic example, we'll go back and answer that question that we left open. So here's your first example. Let's say I have 3x plus y equals 4, 3 and 4, 3 and 4. Okay, there we go. We have here two equations, right? These are both linear equations in two variables, both of them, right? This is a line, this is a line. They're both written in standard form. Remember the different forms? They're both in standard form. ax plus by equals c, ax plus by equals c. Now, we use this notation. We put a big brace out in front when we are trying to let the reader know that we want to find the solution to this system. So can anybody sitting there right now cover this up and give me an x and a y that makes that true? What? 3 and 1.
4 negative 1 or 4 and 1?
4 and 1? Does 4 and 1 work? 4, 1. So 3 times 4 is 12 plus 1, 13, yes. But does that work for this one? What would you get? Negative 8 plus 3? Doesn't work, right? So what we're trying to find here is an x and a y that work for both. That's the goal. But that corresponds to where they intersect, all right? That's the same point. I'm just trying to illustrate that algebraically, we're trying to find an x and a y that work for both simultaneously. All right, so elimination works like this. Substitution. We're going to do substitution here. First step to substitution. Solve either equation for either variable. What? The hell does that mean? What does that mean? I get to look at my equations, and I get to choose which equation I want to solve for, and I get to choose which variable I want to solve for. So I'm going to think about this. I'm trying to be smart about it. If I look at my first equation, what would I need to do to solve for x? If I wanted to solve for x, what would I need to do? Move the y over and then divide by 3, and I'm going to create fractions, right? And I don't like that. I could do it, but I don't like that. How about if I take this equation and solve for y? What would I have to do? Just move 3x over and I'm done, right? That looks promising, right? How about this second equation? Solving this one right here for x would require moving that over and then dividing by -2. I don't feel like doing that. Solving for y, move this over and then divide by 3. I don't feel like doing that. So it seems to me like the best candidate for us is to try and solve the first equation for the variable y. All right? So that's what I'm going to do. I'm going to solve either equation, my choice, for either variable. I'm picking that first one. I'm going to take 3x plus y equals 13 and solve it for y. So y is equal to 13 minus 3x. You could have also written that -3x plus 13. These are equivalent, right? These are the exact same things. Your choice. All right, so what do you do after you solve one of the equations for one of the variables? You take that answer and you, what did you say? Substitute, which is why we call it substitution. We're now going to substitute that answer. Okay, when I say that answer, I mean that answer right there. We're going to substitute that answer into the other equation. All right? So I'm going to box this right now. This is boxed up. All right? I solve for y. That's what y has to be. Now I'm going to jot down the other equation. Here comes the other one. This is the one I did not solve, right? -2x plus 3y equals 6. That's the other equation that I didn't touch. And I'm going to substitute this answer in. What do I mean by substitute this answer into this one? Replace this y right here, right? I'm going to replace this y with 13 minus 3x. And I have to put in parentheses. Why do I have to put in parentheses? Because you have to distribute the 3 through. So my next line is going to look like this. -2x plus 3 parentheses 13 minus 3x equals 6. Okay, I'm going to give you 2 minutes to solve that equation. Here we go, starting now. That is a linear equation in one variable. And then I'm going to call on someone for an answer, and if you get it wrong, I'm going to take off 10 points off your next test. I'm kidding. No pressure. I want you to raise your hand when you have an answer. You should be able to solve for x. You should be able to get x by itself. Okay, good. Yep, that's what everyone else is getting. Yep.
So you find x equals 1. I have a question.
Yep. 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 Yes.
So I'm gonna miss it, but I know we're trying to solve for x.
You missed the x right here. When you did 3 times -3x, -9x. Now collect your x's together.
So I'll just do -2 minus 9?
X, yes. negative 11x
Okay, I think I got it.
plus 39. You still have plus 39 there, right?
Yes.
Equals 6.
I'm not
And
returning.
now,
minus 39.
yep, there you go. And you're on your way. Question or you're good? Yep, that's good. Okay. Anybody have any questions over here? No, we're good? X is, you getting X is 3? 3 minus. No, you were doing the right thing. Let's see. Where, hold on. Negative 2x, negative 11. Everything looks right there. Hold on. Oh, okay, right here. 6 minus 39 is negative 33. Negative 33. And then when you divide by a negative, you're going to get positive 3. That was it. Yes, sir. That's good. You got negative 3?
Yes.
This same thing. Where did the 33 come from? You subtracted, right? Okay, so now negative over negative is positive. Okay, that's 2 minutes.